Hopefully at this point you have your Visual Studio all installed. All I did was create a new project. I'm going to create a console application. From here, I'm going to select .NET 5 to make sure that's my target framework. And I'm going to do a demo of CS1, CS2 topics. And now I have my Visual Studio set up. I'm going to bring out my solution tab just to show the structure of the project. And as you can see here, I have my folders, any dependencies, which we'll talk about later, and then my program.cs. As you can see here, I have a program.cs class with a main method, and we can now almost act like this was a Java program. Some little bit of differences is you actually don't need the string array of args. That is completely optional in C#. Notice we use Pascal casing for the main and for methods. And I will just go through here and demo a few things that I would expect everyone to know. Some of those concepts would fall into variable declarations. Those other concepts are in C#, we can use this keyword called var, and it will take on any data type that is assigned at runtime. So now some string is of data type string. So some string is going to be a string at runtime. This is going to be increasingly important as we progress forward, that we may need to allow the runtime to determine what data type it is instead of us declaring maybe a data type that it can only be, which could be problematic as we progress forward. Let's see here. Has all of the standard kind of plays. So we still have if statements as represented here. We can put an else. So we can have an else built in. A few more things. We could have a switch statement. So a couple other things is we can have a switch statement as represented here. Going on, there's still our for loops. So we can have a for as represented here. And notice that I'm able to use the tab functionality. So all I'm doing is kind of saying for tab twice, builds out the structure for me. Going on a little bit further, there's this for each, which was the enhanced for loop in Java. In C#, the enhanced for loops will loop on a collection. So I can have an int, oops. So I can have an array of numbers as represented here, and I can then, and all I did to print that console was CW tab tab, and so I can, for each through all those numbers, it'll print the 1, 2, 3, 4, one at a time as represented here. We have the while. We have the do while. So all of those structures are still the same. We can have many of the built-in classes that the system class contains. Many of those you might have to look up, but things like datetime is a very popular one here. So and notice here it's part of the system class, so we won't have to worry about any imports. If we do random, as you can see, still part of the system class, no need for any imports. So a lot of the built-in functionality that Java would require to import for, it's part of the system class in C# or in specifically .NET. Let's see here. If we were to continue on, we can build other classes. So I can come, right click in here. I can say add a new class. I can just have an empty class. We'll call this maybe my people. And in here, we are going to talk about, I have my constructor, so we can have my constructor as represented here. But what's really majorly different versus C# and Java is you would have attributes here. And one of the things is we don't have attributes in C# per se. You can have attributes, and I'm going to have a whole video talking about properties and such, but we will be focusing on these classes to have these things called properties. Okay, so you're going to learn about properties. In this week, I'll have a few areas for you to go and research through those. But properties are accessible methods that act as a getter and setter. So in Java, we would have done something along like this, right? So let me back this up a little bit and say we would have attributes. If we were going to do this the old Java way, we would have something like maybe int, and I'm using this underscore just to say that it is a private method. So I would have a private or a private attribute called age, and I would have a private, maybe, let's do this, called first name, and I will add the underscore in front of it just to represent it is a private, and private So in Java, you would have this, and then you would do something like this, right? You would say public, let's call void, and we would do something like set age. And just to let you all know, it would be set age, just to keep inconsistency here. And then you would take an int called age, and you would say this age, and it's actually this underscore age, and hence I don't even need the this part of it, is equal to age, and so on and so forth, right? So that's, you have the setters, and then you would have a getter, public int called getAge. Oops, I am one off on my keyboard hand placement, and you would do return age. So that's your typical getters and setters, but that seems a little redundant to me. And I know that in Java, you learn that you have your simple clicks to be able to auto create setters and getters based off of your attributes. But the only reason you may need to do something like this is if you had to do something special with age. Maybe you did something along the lines of like, if the age that was coming in was less than 0, then you're going to have to do something. So if it's less than 0, I'm going to throw a new exception and say something like invalid age, you can't be less than 0. Okay, and then, so if it's less than, and if not, then I just know that if I throw an exception, termination stops here, so I'm good with just leaving it like this. Maybe that's what I want to do. And notice that with exception handling, I don't have to say throws or anything along those lines. So that's not, I don't have to identify that this throws something. That's the nice thing about C#, okay? So I can really just say public void set age. If I set the age, if it's less than 0, then I'm going to throw a new exception saying, hey, you can't be less than 0. Let the person who's calling on this figure that out for me, okay? If not, I'm assuming rest is age. We can even say if it's less than or 0, or if we want to say if age is greater than, I don't know, let's say 150 for let's just say like maybe 125. Maybe we don't let anybody be 125 years older. Okay. Um, and you can figure out all of the how you want to word the statement here. Invalid age, and this might be a good example where we can use string interpolation. So invalid age, you can't be, and then maybe we throw in the current age that you sent, age, and then we can say something like years old. Invalid age, you can't be, and then whatever number they entered, years old, and if it happens to be all that. So that's an example of string interpolation here. All string interpolation means is whatever that value of age would be interpolated into that string at that location, and we will let the runtime environment handle whatever age turns out to be. And we could do math in there if we need to. This just helps with cleaning how things need to look. So that was a pretty good question there. So if you have something along the lines like you need to do some checks and balances, maybe this would be the appropriate way, but I'm actually going to teach you something that's better than these two things here. And that's going to be called properties, okay? So in C#, we have this thing called prop. It's a keyword, and if I hit tab, it's going to generate this line of code, and it's going to say what data type is it, and we'll say int, and what property do you want to call it? Age. So I'm literally replacing this right here, saying that this is going to be a property called age here, okay? And this would be okay, just like this. This has the get and set. So if we don't have anything special, I know I have a special set age, so I'll figure out how we can master this special setter in a minute. But if we didn't have anything special, like we just wanted to get or set, we can just push that out. We can say, okay, I'll let you get something, but we can say you can't set it. So maybe we have a private set here, okay? So what does that mean? That means that when I want to use this, I can't just get it and I just can't set it. I mean, I can just get it, excuse me, but I can't just go in and set it. Let me show you it as an example. So I'm going to save this really quick, jump over to my program, and I'm going to create a person object or a people object. So people, and it should be person, I know, equals a new people. And so I have this people here, and notice now that I have this property called age, and I can try, it's going to actually give me an error. If I try to set the value, so people.age, I'm actually getting an error. It says the property age cannot be used because the accessor is inaccessible. Well, why is that inaccessible? It is because I have that private set. If I get rid of this, give this a save, go back over here, you'll notice that the error goes away. Now, if I want to use it, right, so I want to print out, and I want to say something like, let's use string interpolation again. This person's age is, and I can just come in here and people.age, and notice that this is going to call on the setter, or the getter. That's the benefit of a property is at time of runtime or at on compile time, it's going to say, oh, I can go out there, grab the age, because I have the getter that's accessible. Right? If I put private and I try to access it, it says, nope, the get is private, you can't access that. So we can manipulate it that way. Properties are super powerful. I want you to use properties. So, for the rest of them, right? Prop, tab, string type, first name, done. Prop, tab, string type, last name, done. So now I have inevitably fixed these attributes. So I'm going to get rid of them. So I fixed these attributes. But so I don't need get age anymore, so that's no longer valid. But now I have this special code on set age. So that means if I come out here right? If I come out here and set age to -12, that is going to apply, but that's invalid according to my logic. So how do we go about to fix that? Well, there in the documentation I'm going to provide you, there is something called a backing field. So I can have a backing field. So I'm going to call it a backing field now. And this backing field is going to look like an attribute. So I'm going to say private int called age. So I'm going to have this backing field. But I'm not going to have this setter. I'm going to leave this setter just to help me with my logic. But now what I need to do is with my age, I need to not just use the standard get and set. I actually need to come out here and I need to write code that makes my set and get work the way that I want to. Okay? So I'm coming out here, I'm just exploding this out. Now it says I have an error. Well, why? What do we want to do with get? Well, let's figure out what we want to do with set first, and let's see if we can get this working. So I kind of have the logic here. I have this if statement for the logic. So on the set, I need this logic to run. Do you all agree? But the problem is where do I get age now? Age is not a passed-in property. You're absolutely right. When we use this right here, this -12 is going to come into a keyword called value. So when I call on this part right here called people.age equals a -12, so I'm trying to use the setter here. This 12 is going to get passed to this class, okay? And it's going to come in this thing called a value. So if the value is less than 0 or if the value is greater than 125, then we're going to throw the new exception and we'll just say, hey, the value is incorrect. If it's all right, then I'm going to use the backing field and say the backing field is now set to what the value came in. So this should feel very similar, okay? So we're going to have this backing field filled with this here. And now on the get, I can simply just return the backing field. So that should be a pretty simplistic piece of stuff for you. So what I represented here, so these are properties. So everything from here to here. So this is a property, and we'll say end properties. But this one called age, this is a property with backing fields, with a backing field. And these right here are just standard properties. So let's see this in action. So all I did was I cleaned up the main method a little bit, and I have this people here. So let's see this out. So if I say CW and I say people dot, let's get some age. Well, what do we expect for this to print out? So I'm going to hit the little play button. And it printed out 0. Well, why did it print out 0? Because ints, if I don't give it any value, it's an int type, its default value is already 0. So we're good there. So let's try to change it. So people.age, and I'm going to use it as a setter. And how am I using it as a setter? Because I'm going to assign it an integer type over here. So I'm going to say, let's enter 50. So now people.age equals 50. That means 50 gets passed to this property. So it goes to the set. So 50 is in value. Is 50 less than 0? No. Is 50 greater than 1? No. So that's 2 falses. So we jump here and we say 50, assign it to the backer, age. So at this method right here, or this property on line 11, calls on that setter and sets it to 50. We're good there. Console.WriteLine, people.age. This is calling it from a set perspective. Why? Console.WriteLine requires you to give it something, so an integer, a string, or some kind of data type to print out to the screen. So it's going to call on the getter. So it goes to the getter. It says return underscore age. So whatever value is an age. So when we set 50 to age, at this moment in time, it's 50. So when I run this, it should print out 50, as it did. So got our 50. Good to go. So what happens when I do something that's wrong? So 126. So if I run this, I get an exception thrown. My whole system says invalid age, can't be 126. So I should probably throw this into a try. So I should try to set the age. And then if I catch an error, maybe I should do something along the lines of, we'll just see we'll just print out the exception. Okay, so we'll run this now. Whoops, let me rerun that, then exit out. So as you can see here, can't run it through the exception. It is set to 0 just because, the value is initiated to 0. So it told us what the exception is. A better programmer would do something with this, not just throw the exception, but just to show like, hey, we can do that. So here is a basic properties with backing fields, talking about an age backing field. Here's a traditional property. Now let's see first name and see that in action, right? I can come in here and let's do this a true number so we don't have to worry about any exceptions. And let's do something like this. So got the people, we'll say first name. I'll put my name in there. Let's put my last name in here. And there we go. So now I can say something along the lines, I'm not 50. Let's make this more better. So we'll say something. Let's use string interpolation again. Hello. My name is, we can say, well, let's get people dot, use the getter now, first name. And actually, yeah, let's do it this way. Why did I not put them together? Well, because I wanted the space to actually do it. And so maybe I do last name. Hello, my name is Matthew Desjardins. We'll grab the age. So people age. All right. Years old. Let's close that string interpolation down. Now if I run this, and there we go. Now I would, if I do this a lot, maybe I create a method. So let's just come down here and maybe I say public string, we'll call this full name. And I can simply just return, and I'm going to use string interpolation here. I can just return first name space last name. Boom. So now instead of having this, I can just string interpolate people and I can get that full name method. And I should get the same results as shown there. All right. I'm going to take a quick break here, give a pause. I'll probably break up the next couple topics into some videos, but here I represented a main method accessing a class. So everyone should be familiar. They're shown a simple exception being thrown. Properties. We can now get rid of this method, so I'm going to clean that up. I know I don't have a constructor, but a constructor, this is just the default constructor. So if I don't have one, I'm just going to get rid of it. We'll just let the default constructor kind of handle it. Shown how the main method runs. and very, very basic concepts. So hopefully everyone understands these concepts. I'll come with another video highlighting a couple more things. We'll talk a little bit about inheritance in the upcoming videos.